This is a difference of squares. So this is special because both numbers are squares. So let's start with the idea of what a square is first of all. Squares are 1, 4, 9, 16, 25, 36, 49, 64, 81, and 100. There are some more. 100, that's 10 squared. 121, 144, 169, 196, and 225. So those are the perfect squares through 15. Remember that a square is a number that's the same number times itself. X squared is a squared. So like we can do all those things. And so when we're factoring a difference, what does difference mean? Difference means subtract. So when we're doing a difference of squares or a subtraction problem with squares in it, the process is a little different. Shh. All right. Which is not what I want to see. What am I looking at? So we're factoring a difference of squares. So these first three things I want to remind you about foiling. Shh, stop. Okay, so x times x, x squared, x times negative 9, negative 9x, 9 times x plus 9x plus 9 minus 9. Multiplied is negative 81. So when I multiply, or when I combine like terms, x squared minus 81. So notice we went from 4 terms to 2 terms because the middle terms cancel out. For the second one, 5x times 5x, that's 25x squared. 5 times positive 7, that's plus 35x. Negative 7 times positive 5 is negative 35x. And negative 7 times positive 7 is negative 49. Again, when I combine like terms, I have 25x squared minus 49 because the middle terms cancel. The last one, 2a times 2a is 4a squared. 2a times negative 3b is negative 6ab. Positive 3 times positive 2 is positive 6ab. And plus 3 minus 3 multiplied is negative 9b squared. So when I combine like terms, I get 4a squared minus 9b squared. Because in each of these middle terms cancel each other out. So I want you to look at what we finally ended up with. X squared is a square, obviously. 81, that's 9 times 9. And this is the difference. So this is a difference of squares. So how come, I want you to notice, we started with 2 terms, but when I factor it, I get x plus 9, x minus 9, because I need these 2 middle terms to cancel. So a difference of squares is just the square root of each of these with 1 negative and 1 positive. So the square root of 25, that's 5, and the square root of 49, that's 7, with 1 negative and 1 positive. So when we multiply this out, that's a squared plus ab, but then it's minus ab minus b squared. These cancel so that I get a squared, minus root b squared as our final thing. That's how we multiply. There is not a rule for the sum of squares. So the square root of x squared is x, and the square root of 4 is 2. So you might think that that's x plus 2 squared, except x plus 2, please stop doing that, x plus 2, that gives me x squared plus 2x plus 2x plus 4, which is x squared plus 4x plus 4. This is not the same thing. This does not work with that rule. These are not the same thing. They're not equal. So there isn't a rule for the sum of squares, only for the difference of squares. There is no rule for this section because it's not factorable. It can't be eliminated when I have a positive c. But when I take the square root of both of these, I get a, and the square root of b squared is b, so then I get a minus b, a plus b. So this is the rule. So if you could just remember, you take the square root of both numbers and you add one and subtract the other, that'll be how you can find the difference of perfect squares. So we'll go through the steps again and then we'll do some practice. So first, make sure that you have an actual difference of squares. You have to have a subtraction sign, and you can square root both terms. And then we use our rule. Take the square root of each term, write those in parentheses, and then make sure that one is positive and the other is negative. So we'll go through those steps and I'll show you how it works in a problem. So we're going to take the square root of both numbers. Square root of both numbers, then we write those in parentheses. So we're going to have something that looks like this, and we'll have a and b and a and b, and then you make one positive and one negative. And that's how we're going to do that, okay? All right, so let's look at this first one. First, we make sure they're both squares. This is a square, obviously. Is 64, are there two numbers that multiply, or is there a number that multiplies by itself to be 64? 8. So we take the square root of both. And so this is just the steps. We're going to do this every time, but we're going to do it for a little bit. So the square root of x squared and the square root is 64. So I get x and 8. So then we have where this is a and this is b. So then it's a minus b, a plus b. So then it's x minus 8, x plus 8. And that's the answer. Once you get the square root of both numbers, you just put them in there with one positive and one negative. But you have to make sure the number you have actually is a perfect square. So x squared is obviously a square. What's 81? What number times itself is 81? 9. So the square root of 81 is 9, and the square root of x squared is x. So then I have 9 minus x, 9 plus x. And that's it. Sometimes there is a coefficient in front of the x, and you have to make sure that it is a perfect square as well. So this is a perfect square, is 9. Is there a number times itself that equals 9?
Yeah.
What number times itself equals 9? 3, that's right. So then we have the square root of 9x squared is 3x, and the square root of 100 is 10. So then it's 3x minus 10, 3x plus 10. That's it. Once you find the square roots, it's just minus and plus, and that's all we need to do. All right. X squared is obviously 1. What is the square root? Is 16 1? Can I take the square root of 16x squared? What's the square root of 16? 4. And the square root of x squared is x. And what's the square root of 121? 11. So then I get 4x minus 11, 4x plus 11. The order of these two symbols doesn't matter. It can be plus and then minus. It doesn't matter. I just do the minus first because it's a difference, and I just do a minus first. It doesn't matter which one you do. Which one? Do I have to have this x? No, because see how this is negative? The negative goes with the 11. Make sense? Okay. All right. Now, this is different variables, but it doesn't change the fact that everything there is a squared. So when I do the square root of 36x squared, that becomes 6x. And the square root of y squared is y. So I get 6x minus y, 6x plus y, and that's it. Go back. Sorry. So it's just a combination of finding the square roots. So on your blue cards, it would be handy for you to highlight or circle all of the perfect squares. 4, 9, 16, 25, all the way up to 100. And maybe on the bottom, write up to 100, up to 225, up through 15. On lots of tests, the ACT, the ASVAB, lots of tests, they expect you to know that like the square root of 400 is 20. And 625 is the cube root of 5. Like they're just, or fourth root of 5. They expect you to know those kind of things from interacting with numbers so much through your career. All right. Square root of both sides. Square root of 4x squared. Square root 25y squared. That's 2x and 5y. So 2x minus 5. 2x plus 5. That's what we're trying to figure out. Does that one look worse? Number 7, does that look worse than the ones we've done so far? Why? Because there's 2, but they're both squared, right? So what's the square root of x squared? X, and the square root of y squared? Y. And then 1 is a perfect square. Don't forget that 1 is a perfect square. 1 times 1 is 1. So then the square root of 1 is 1. So following that pattern, I didn't write this all the time, but you should, because this is A and this is B. so that I get xy minus 1, xy plus 1. And if I need to check it, I can just, okay, xy times xy, that's xy squared. This becomes plus xy minus xy. Those will cancel. Those become 0. And then negative 1 and positive 1 is negative 1. A number 8 is a trick. Why is number 8 a trick? What makes number 8? No, that's okay. Variables in both is fine. Is 4 a perfect square? What's the square root of 4? Square root of 25? And y squared and x squared can both do that. What makes it a trick? The addition sign. We've been working on a difference of squares. This is a sum. So when we do this, when we take the square root, so the square root of 4x squared and the square root of 25y squared, that's 2x and 5y. So then if I follow the pattern, that's 2x minus 5y, 2x plus 5y, right? So if we follow the pattern that we've done, that's what's factored. Except when I multiply this, that's 4x squared minus 10y xy, sorry, plus 10y minus 10xy. I tried to cram too much in there. 10xy minus 25y squared. These cancel, so I have 4x squared minus 25y squared. These two things are not the same. Because it's a sum, it's not factorable. So pay attention. Just because you're working on a process and you kind of get in the habit, oh, we do this and we do this and we do this, don't go so quickly that you don't pay attention to the signs. Sums, a difference, the sum of squares is not a factorable thing. All right, these have a GCF. So just because you look at it at first and you go, oh, there's nothing I can divide those by. 2 isn't a square. 72 isn't a square. But they're both even. So I can divide by 2. So when I divide by 2, I get 2 times x squared minus 36. Now, it's a difference of squares. So now we take the square root of x squared and the square root of 36 so that I get 2 times x minus 6, x plus 6, all because I factored out that 2. So you can't look at a problem and automatically go, well, that's not a difference of squares. I can't do that one. You have to follow through and remember that you can take out a GCF or simplify your fractions to make it something so that it will be a difference of squares. Now, as much fun as this is, please keep remembering that this is last year's math. We did this last year for sure. And probably the year before that a little bit. Definitely the first couple of days. In fact, 100 is working on this right now. They're still back on GCFs, but they're working on this right now. All right, let's look at number 10. 45 and 20 are not perfect squares. And X cubed and X are not perfect squares. But what can I divide both of those by? What's the greatest common factor between 45 and 20? Go look on your card. 45 and 20. 5 is the greatest factor. And there's an X in both terms. So my GCF is 5X. So when I divide by 5X, I get 9x squared minus 4. Now, it's a difference of squares. So when I take the square root of 9x squared and the square root of 4, I get 3x and 2. We bring this down, so I have 5x, 3x minus 2, 3x plus 2.